Right, so for the second presentation, it will be presented by Dr. Maizura Ibrahim from Agency Nuclear Malaysia, if I'm not mistaken. And she will talk about applying empirical method for performance metric measurement of a nuclear security system. So I think I left this floor to you, Dr. Maizura, for your presentation.
You, Mr. Main. I hope I'm here out here, but unfortunately I cannot share the screen here. The button is unavailable.
Oh, meaning that in your panel, in the bottom panel, you don't have share button?
Yes.
So I think we can share it for you, I think.
Okay, thank you.
Please wait for a while.
We are a team from Information Technology Application Center, Technical Support Division at Agency Nuclear Malaysia. Okay, proceed to the next slide. All right. First, I would like to give some introduction about nuclear security definition. So here, nuclear security is the prevention and detection of and response to theft, sabotage, and unauthorized access, illegal transfer of other malicious acts involving nuclear security, other radioactive substances, or their associated facility. This is a definition in the IA nuclear security series, and here I would like to highlight the context of this paper is about nuclear security system, which is the application system or software that is developed to provide the nuclear security. All right. Okay. Next slide. Okay. For the background of the study, we have here a nuclear security system is often developed based on a particular framework. And here, in our case, our nuclear security system is developed based on the big data analytic framework. This framework, besides provide for nuclear security, we also aims to integrate all the nuclear security subsystem within within these nuclear facilities through the framework. All right, next. So the system-based evaluation methodology is widely used in measuring the performance metric of application and software. This is in the information technology domain, where system-based evaluation is mostly used to evaluate the performance metric. However, the system-based evaluation methodology consumes time and demands a lot of effort. Okay, in this paper, we present an empirical method of measuring the performance metric by utilizing the RASH measurement model. The proposed methodology is formulated to reduce the times, efforts, and process complexity in measuring the performance metrics. Okay, next. This work is related to the work by the World Institute of Nuclear Security, which is published in 2015 and published in two reports. And next. Okay. This paper also present a method proposed for our previous work, which is for validation of our previous work that is published in these references. Okay, next. All right, empirical method. While the system-based methodology is widely used to measuring the performance metrics of application system or software in IT domain, in nuclear security domain, theoretical or hypothetical based techniques is widely used. Okay, this is presented in the IAEA Tech Doc entitled Nuclear Security Assessment Methodologies for Regulated Facility, Norazam, which use hypothetical base, and also in the nuclear security series number 4, also use hypothetical base. And here empirical methods that is used in our work is we refer to the any procedure for conducting an investigation that relies upon experimentation and systematic observation rather than theoretical speculations. Next. Okay, this is the proposed empirical method for measuring the performance of our nuclear security system. Okay, our nuclear security system are based on big data analytic frameworks. Therefore, we have developed here 9 process to measure the performance metric, which is an empirical based method. Okay, the first one is we develop the big data analytic nuclear security framework itself. And then the second one is when the nuclear security framework is ready, we have to identify the peculiarities of the element of the frameworks. This is considered the performance metric for our work. And then the third process is to identify and develop the pilot environment for the evaluation. Okay, in this method, we detail out the environment for pilot testing, for pilot evaluation. And then the next one, we design and develop the survey questionnaire based on the pilot environment. Okay, here we use online platform to distribute the survey. And then after that, after the questionnaire is given to the specimen, and we connect we collect the result, and then and that is the implementation of the pilot evaluation. And then after that, we evaluate the pilot evaluation result using the rush measurement model. Here we want to validate that whether the pilot environment is result give us the acceptable result or not. And in rush measurement model, we have techniques to determine whether the result is acceptable or not. And if they are not acceptable, then we have to go back to the third process, which is we have to re-identify the development and for the pilot environment. And then the next phase is to implement the real environment. If we got the acceptable result, and then we implement it, we implement the survey to the real environment, and then we evaluate the result and analysis using RASH measurement model. And then after that, we have after we have the result, we present and report, and the process will be end. Next. All right. This is the methodology comparison based on 3 methodology name, and then the properties that we are evaluated, that we are evaluate. Okay, the first one, the first methodology we evaluate is the system-based evaluation methodology, and then the second methodology is the theoretical and hypothetical base, and then the third methodology is the empirical base, which is our methodology. Okay, in terms of requirement, we have for the system-based methodology, we need to develop a complete system. A complete system needs to be designed, developed, and implemented in the nuclear facility environment before the performance metric could be measured. And then the second, for the theoretical, hypothetical based methodology, of course, you don't need to have a complete system, but you need to design the DBT. Thus, DBT must be developed first. And then for our methodology, we didn't need DBT or a complete system to be developed. We only need the framework that is going to be used as the basis for the application system development. And for the time consume properties, for the system base, we have long process, and for the theoretical base, it is moderate, and for empirical base, we have low time consume, because it is considered low time consume. And as for the risk, high risk for the system base, as it's you have to have a complete system, and then if the system fail, and then you have to go for a long time process again to evaluate the system. And then for theoretical base, we consider it low risk. And then as for our empirical based methodology, we have we consider it low risk. And in terms of process complexity, you can see that system based evaluation is very high, and theoretical based methodology is very high. It's high. And then in terms of complexity, the empirical based methodology is very low. Okay, next. Okay, in conclusion, in this paper, we propose a methodology for evaluation of nuclear security systems. The key element of the methodology are developed by applying empirical method, implemented by distributing the online survey questionnaire, and this online survey questionnaire could be re-implemented on any survey platform. And then we apply rush measurement model in analysis and constructing the result, and this is a very precise cycle evaluation. And this methodology has low time consume, low risk, and low process complexity compared to the previous methodologies such as system-based and theoretical or hypothetical-based methodology. Next. Okay, I would like to acknowledge the IEA and the research grant J0 2011 for providing the grant for this project. Next. And this is the references. That's all for my presentation, and thank you very much.